Hey guys, welcome to Pandemic Learning 2020. If you thought the coronavirus was going to stop you from having to learn physics, you were wrong. So, as we are still kind of figuring everything out for the next couple of weeks, I want to lay out what my plan is for you guys during our classes. So, every day I will post a YouTube video in this channel. I will have linked it to Google Classroom, and with the YouTube video will be worksheets and resources for you guys. All of that will be hosted on our Google Classroom site, so you can all have access to it. I'm not going to give you anything that you have to print out. You can do everything on scratch paper and just kind of, if you number it for yourself, that way you can keep track of it all. I'm going to recommend you take notes during all of our videos. Crazy, I know. But the goal of this time is that we kind of keep moving forward and don't lose any of the skills that we've spent, 3/4 of the year building up. So with all that being said, we'll do the YouTube videos, and then every day from 10:30 to 11:30, I will host a virtual Zoom meeting. So Zoom is kind of like Skype, and if you've ever done that, and it will allow us to correspond face-to-face via a computer screen. You can see me actually work out problems. You can ask me questions, and you'll actually be able to kind of work together through things because we can all kind of share screens. So I'm not going to tell you the Zoom sessions are required, but I would highly recommend you attend. I can't tell you that this work that we're doing is required, but I'll tell you this much. When we get back to class, I'll be collecting grades for all of this. So you do you, but I'd recommend you kind of stay on top of it so you're not shooting yourself in the foot at the end of the quarter. So in today's video, we're going to do a couple of things. The first thing I'm going to show you how to do is download a graphing calculator app on your phone. I know a lot of you don't have a graphing calculator at home. This is going to be our workaround. I will use the app as well in my videos, so that way you can kind of see how to work it. If you have a graphing calculator, just use that. The next thing we're going to do is we're actually going to do a Unit 4 post-exam review. Essentially, it's the version 2 of the exam. I'm going to kind of lay out the beginning steps for each of the problems. And then your job is going to be to go through each of the problems, actually solve them, and then submit your answers in the Google Doc that is posted on Google Classroom. So let's get into it. Okay, so first thing, go to your app store, whatever you have on your phone, and you're just going to type in graphing calculator. And you should come up with one that either says x84 or TI-84. Honestly, it'll be the same thing. So you want this one right here, graphing calculator x84. It should work just like a regular graphing calculator. Get it, double click to install it. Use your Face ID if you need to, whatever. But it's a free download and it should work just like a regular graphing calculator. And we will kind of learn how to use this together, but let's double check one of the first things we want to do. What kind of mode should we be in? Degree, miss. So click mode on your calculator. I'll do that one more time. Click the mode button and make sure angle it's on degree. All right. The rest of this, normal, this is all fine. Okay. So once you have that done, you can exit out and then you are able to use your phone like a graphing calculator. Okay. All right. Now let's move on to our Unit 4, Work, Power, and Energy Post-Exam Review. So, like I said, I do not expect you to have this printed out. What I would recommend is that you grab just a regular notebook, have the exam pulled up on your computer screen. Ooh, what the heck is that? And just kind of, number it along with me so you can have all of these notes written down, and then when I can actually give you a physical copy of this, you can just kind of staple all of your work to the back of it and move on with your life. So I'm going to kind of give notes for each of these problems, and I would recommend that you write whatever notes I'm writing in your notebook with the associated problems. So if you are unable to do a split screen on your Chromebooks, I'm not really sure, I would recommend maybe pulling up this document on your Chromebook and then kind of playing me on your phone as we go through this. Feel free to pause me at any point in time, and let's go. So, first problem, Work is only done when the force and the distance vectors are blank. So, if we have an object and we are pushing it this way and it is moving this way, what is the angle in between these two vectors? It's 0 degrees. Let's take a quick second and talk about what is the formula for work. Hopefully we all remember that work is equal to F delta D cosine of theta, where theta is this angle between two vectors. So, if my theta is 0 degrees, we are looking at this option choice that is parallel. Because remember, perpendicular means that they're working at 90 degrees. Okay? So, going to our handy-dandy calculators, let's just see what the cosine of 0 degrees is. So we'll type cosine of 0, and we get 1. So that means no matter what my force vector is, no matter what the delta D is, I am multiplying it by the number 1, so I will actually get a value. Our answer here is B, parallel. Work will only be done if force and distance are parallel, and that can be found in the PowerPoint that we originally went through in class, where we were talking about what work is. Okay, sorry about that. So let's talk about the next one. How much work does the force of gravity do on a 5 kilogram box sliding horizontally across the ground for 10 meters? So we're going to take a second and draw it out. Here's my little box. It's moving horizontally, but the force is acting down. So work equals F delta D cosine of theta. Our force is the force of gravity. So let's talk for a second though. Delta D obviously is 10. What's the angle in between these two vectors? It's 90 degrees here. I want you to, as you are solving this problem, just do the cosine of 90 degrees, figure out what it equals. That will tell you what your answer choice is, okay? Because if you notice, our answers are either 0 or 490 as the number. You then need to think about units. What do we measure work in? It's either joules or watts. I'm going to leave that up to you to figure out, okay? As our setup for the next problem, okay. Under the influence of a force, an object of mass, let's write that down, M equals 10 kilograms. It's accelerating from velocity is 4 meters per second to 10 meters per second in 8 seconds. And we want to know how much work is done. So VI equals 4 meters per second. VF equals 8 meters per second. And we want to know the work done. So, I want to remind you here that work equals a change in kinetic energy. Whenever we see change, we know we're talking about final minus initial. So if I want to know the work done, we can use this information to find the change in our KE, and that will equal our work. 1/2. Let's remind ourselves too, KE is 1/2 mv squared. So our change is going to be 1/2 mass times VF squared minus 1/2 m times VI squared. Plug in your numbers, get your answer. Moving on to number 4. A 2 kilogram car collides with an initially stationary 3 kilogram car. We're talking a collision problem. That means we're talking conservation of momentum. So let's start with M1 is 2 kg, M2 is 3 kg. If mass 2 is initially at stationary, that means it's at rest, so VI2 is 0 meters per second. After the collision, they stick together and move with a velocity of 0.5 meters per second. If they stick together, that is an inelastic collision, and so we know they have the same final velocity, Vf, equals 0.5 meters per second, and we want to know what's the speed before the crash. So this Vi1 is a question mark. All right, if you look at the PowerPoint from earlier in the Google Classroom, it says conservation of momentum. You can find the exact formula. I'll put it right here though. It's M1 Vi1 plus M2 Vi2 equals parentheses M1 plus M2 Vf. We are only able to use this formula because they have the same final velocity. Okay? And remember, our momentum at the beginning has to equal our momentum at the end. So, from here, you're going to plug in your values. All right? 2 times Vi1, because we don't know what it is, plus 3 times 0 has to equal 2 plus 3 times 0.5. They didn't specify directions, and because they didn't specify, we can make the assumption that everything was moving to the right. Okay? Plug in your values, solve for Vi, pick your answer choice. Okay? Moving on. A 10 kilogram coyote is on a rocket. It's accelerated, so hold on, M is 10 kg. Notice that I'm writing the givens every single time. What do you think you should be doing on your scratch paper? Probably writing down the givens every single time. Crazy, right? The force is 10,000 newtons from rest, so that means Vi has to equal 0 meters per second. And we want to know the kinetic energy after 100 meters. So delta D is going to be 100 M, and we want K E. This problem's going to be a little bit more work, but it's okay. We got this. So, there are a couple ways that we can do this problem. I'm trying to think of the easiest way for you guys to do it. So, let's do it like this. So, let's start with what we know KE is. KE is 1/2 times M times V squared. So, we're asking after that 100 meters. So that means it's not the initial velocity, it's actually our final velocity. So, we need to find our final velocity. So I know it's been a minute, and I know you can't see the anchor chart, so I will remind you, because it would have been up on the board, that we can use this formula, A equals Vf squared minus Vi squared over 2 delta D. Because we know Vi is 0, we know delta D, and if I know F, we can always find our acceleration. So we'll use F equals M times A. So, you will plug in values. This is the first equation that you will use. Once you plug in your F and your M, you'll find A. You'll plug that in here to this equation to solve for Vf. Then, once you know Vf, you can go back to this third equation to find the kinetic energy. Okay? If you have questions about this one, please make sure you are marking it. If you have questions about any of them, mark it so you can ask me during our Zoom session, okay? So, moving on. Problem number 6. A 75 kilogram girl, so M, oh, I see there's another mass in here, so I'm going to call this M1, 75 kg. Standing on a skateboard, moving at a speed of Vi is 2 meters per second, and holds a 7 kilogram pile of textbooks. That's going to be our M2. She throws the textbooks behind her with a velocity of 4 meters per second. So Vf2 is going to be 4 meters per second. And we want to know the girl's final velocity, Vf1. So now, we were only given one initial velocity, but we have two separate final velocities. This is an example of another inelastic collision where our objects are traveling together and then separate. Okay? So they're traveling together at the same speed, and we are assuming they're moving forward. Okay? If I throw the textbooks behind me, is that going to be +4 or -4? It's going to be a -4 meters per second. Okay. Now, we can use an equation similar to the one we did in problem number 4, but instead of the parentheses with the M1 and M2 being on the right side, we're going to put them on the initial side. So it's going to be M1 plus M2 VI equals M1 VF1 plus M2 VF2. Okay, remember that these 1s and 2s are subscripts, so just to identify these numbers, they are not squaring. We are not squaring anything in these collision problems. All right, plug in your values, find your answer, mark it down. Number 7. A soccer ball is rolling with a momentum of 6 kgm per s. Now remember, momentum is p. So little p for momentum equals 6 kgm per s. When it's kicked, it gets an impulse, that's J, of 100 Newton seconds. So J equals 100 Newton seconds. Afterwards, what is the momentum of the soccer ball? So this is an initial. We want PF. You guys are going to laugh when you see this. This is one of the easiest ones. J equals F delta T equals delta P equals M delta V. Do you guys remember this equation? It's like my favorite one because you just take any of the two pieces and you can set them equal to each other to solve. So in this case, I don't know anything about this. I don't know anything about this. But we can say J equals a change in momentum. Remember, change means final minus initial. So J equals PF minus PI. Should be pretty straightforward. Just plug in your values and you can solve for PF using your inverse operations. Okay, let's move on. Okay. A small electric motor is used to lift a 6 kilogram mass at a constant speed. If the mass is lifted a vertical distance of 10 meters in 20 seconds, what is the average power developed by the motor? So this is one of the tougher ones. Because we are moving up and down, we actually need to think about the force of gravity at play. So let's see. Our mass is 6 kilograms. A constant speed tells me that acceleration of the system as a whole is 0 meters per second. Okay? We're moving a delta D upwards of 10 meters, and it happens in delta T, 20 seconds. We want to know the power. So power, capital P, is equal to work over a certain amount of time. So if we want to find the power, we first have to find the work, and we need to remember that work is F delta D cosine of theta. Now, we are moving with an acceleration total of 0 meters per second, but some force has to be lifting this block. So this is where we need to think about the entire system as a whole, and we need to go through and say our sum of forces in the y direction, which we've got our force that we are applying to actually lift it, plus our force of gravity will equal the mass of the block times our acceleration of the whole system. So, thinking about that, we'll have our applied force that we're trying to solve for, plus, let's do a little side calculation to get Fg. Fg, remember, is going to be mass times that negative 9.81, because that's acceleration due to gravity. So we'll do, what is it? It's 6 kilograms times negative 9.81, using our calculator. We've got 6 times negative 9.81 Our force of gravity is negative 58.86. Please take the entire number. Do not round it till the end. Negative 58.86. Okay. And that's going to equal our 6 kilogram mass times the acceleration of the whole system, which was 0. Okay, anything times 0 goes to 0. So we know that Fa plus this negative 58.86 equals 0. So to get Fa all by itself, we'll add 58.86. We'll get our applied force is 58.86. Once we know that, we can plug this into here with our delta D. Our theta, if we are pulling it up and it is moving up, what's the angle between the two vectors? It's going to be 0 degrees because it's moving in the exact same direction that we're pulling it. So, take your force, plug it in, delta D, plug it in, cosine of 0 to get your work. Once you know your work, you can plug it in to your power equation. All right. Next one, which situation shows a decreasing potential energy? So we are trying to reduce the amount of possible energy. So, option number 1, a person stretching a bowstring. I want you to think about if you've ever snapped a rubber band on someone. When you pull it up, right? You've got your rubber band and you kind of pull it this way. Does it have more energy like this, or when you start to stretch it? Well, if you let go of it, which one's going to travel farther? Right? So, this is actually increasing potential energy. A cat climbing down a tree. So this is a GPE problem where we've got M, G, and H. If we are decreasing H, we have to decrease GPE. There we go. And then just to double check, climbing a mountain, you're actually going up, so you're increasing your energy. A kite rising with the wind, again, you're going up, so it's an increase in energy. All right, we'll do number 10 together, and then we'll pause the video there, and we'll kind of do this over 2 days so you don't have too much to do all at once. So, number 10, your brother is upstairs 6 meters above you and calls for you to toss him the 2 kilogram remote. So M is 2 kg. How fast do you have to throw it so it reaches him? This is a velocity question. All right. This is also an example of conservation of energy. Remember, conservation means that what we have initially and what we have finally has to stay the same. So, the original setup for this equation is that KEI, so kinetic energy initially, plus the PE, potential energy initially, have to equal the kinetic energy at the end plus the potential energy at the end. Remember, energy cannot be created or destroyed. We can only change it from one form to another. Okay? In this case, we're going to take kinetic energy and turn it into potential energy. If someone catches the remote, we know our final velocity is going to be 0 meters per second. And we know its final height is 6 meters above where we started. So we can just say HF is 6, and then we can say HI is 0. Because it doesn't matter where this happens, it just matters that we are going up 6 more meters. Okay? So, breaking down each of these equations, we've got 1/2 mvi squared plus mg hi. It's got to equal 1/2 mvf squared plus mghf. Plug in all your values, and as a reminder, G is a positive 9.81. Okay, plug it in, get VI all by itself. Make sure you don't forget that this is squared, so you'll have to do some square rooting. Find your answer and mark it down, and then make sure you submit all of these answers in Google Classroom. Okay guys, so we're going to wrap it up there today with content. Just do problems 1 through 10. I will have if you go on our Google Classroom, there's going to be a Google form to fill out where you can just put in your answer choices for problems 1 through 10. submit it and you'll get immediate feedback on that, so you can kind of keep up to date with whether or not you're doing these problems correctly. I will have our first Zoom session available. I will do one tomorrow, which is Wednesday, March 18th from 10:30 to 11:30. And then I'll do another one on every weekday after that. If you're unable to attend them, again, it's not the end of the world, but it'll be an opportunity for you to ask me actual questions, and I'll have a whiteboard available so we can really work through these problems if you have any additional questions about them. Just to kind of wrap it up, let's talk about Zoom. So it's a free app. If you go on your smartphones, you can just go to your App Store. Sorry, I'm doing it right now. App Store, and if you type in Zoom, it's this one right here. It'll be the top one. It's got the little blue camera. Download it. And then what you can do is if you go to Google Classroom on your phone, I will put the link to join the meeting in Google Classroom. You'll click the link on your phone and it'll open right up and we'll be able to meet and talk and it'll be a great time. If you have any questions between now and then, please send me an email. All right? I really miss you guys and I look forward to seeing you and I'll talk to you soon. Bye.